let me know. Just put up your hand or something. I'm counting on you. All right. Well, thank you to the TechTalks team for bringing this wonderful crowd, and thank you all for being here. I'm very, very happy to have you here at Cohere. And yes, what we do here is large language models. So if you're here, you will be as excited as I am about large language models. Every 10 or 15 years, there's a huge advance in technology, and we had personal computer, then we had internet, then we had mobile apps, and definitely generative chat is the big thing right now. So the last year, you must have played with it and seen how wonderful it is. So before I get into these things, I'm going to tell you a little bit more about Cohere. So what we do is large language models. So we want to empower every developer and enterprise to build products and capture the business value with well-being language AI. In other words, if you're writing code and you need to use a large language model, you need to use chat, or you need to use like a chatbot, like search, anything classifying. You don't need to train that model yourself. You just use the one that we trained with lots and lots and lots of data, huge computing power, and you don't have to worry about that stuff. So it's kind of like, I see it as like a power plant, right? Like you plug it into the electricity, and all you have to worry is about doing your thing, and the electricity will come. So in this way, the large language model will come in, and all you have to do is put your endpoint, and it works with an API call, and it is cloud agnostic, so it works in any cloud environment that you have, or in your private environment as well. So a little bit about the models. We have mostly generation, which is when the computer talks back to you and just generates language, and embeddings, which I'll tell you a little bit more about them in a bit. And the right points are this ones: generate, summarize, embed, re-rank, chat plus RAG. I'll tell you about those things. Cluster and classify. And then on top we have Cohere, which I will give you a demo later today, which is basically the chatbot. And custom Cohere, which is you can actually customize this to your own. So if you work at a company and you want to make it only answer questions about the company, then that can be done. All right, enough of the technical stuff. This is pretty much how a large language model works. The Cohere one, ChatGPT, anything like that. You input stuff, and then it just talks back to you. So people tend to imagine it as like a brain that talks and that hears and talks back. I actually want to dispel that notion a bit, because I like to see it not as one brain, but as two brains. And the two brains are one that understands and one that talks. It's very important to see it this way. And when we look at our endpoints, they're pretty much, some of them are understanding the language, embed, cluster, etc. And some of them are generating language like chat or summarize, etc. And actually, language understanding is super, super, super important. So let me tell you about embed. So what's an embedding? An embedding is pretty much the bread and butter of large language models, the most important part of it, because it's really where the rubber meets the road, right? An embedding is when the translation happens from human to computer, because humans, we talk in words and sentences, and computers talk in numbers. And the better we can translate these from one to the other, the better the large language models are. So this is pretty much the bridge. If somebody comes up with an embedding that's 10 times better tomorrow, all large language models will be 10 times better, because it's really where the translation happens. And with really good embeddings, you can do things very easy. So like things that 10, 15 years ago were very hard to do, like classification or something, with a very good embedding right now, you could do it with a little bit of data, like you needed tons and tons of data before. So what's an embedding? Well, I have a quiz for you, okay? And the quiz is the following. Let's say that these are all words. So here you have a strawberry, a banana, a bicycle, a house, tennis ball, etc. And the question that I have is, where would you put the word apple? Would you put it at A, B, C, or D? So who wants to answer? Yes. C. Okay, one vote for C. Who votes for C? Put up your hand. Who was for anything except C?
I think A and C.
A and C.
Where would A be?
A and C.
Why A?
Shape.
Yeah.
Because of shape.
Because,
Yeah.
oh, that's not bad. Yeah. Okay. Okay, I wasn't expecting that, but good. Shape could be an A, yes.
I can argue B.
Why would you argue B?
I don't know, maybe Apple the company.
Oh, Apple the company is like a
It
castle.
says
Yeah, that's a
the
good point.
word, not the fruit.
Great points. I was thinking C, but thank you for your wonderful idea. As a matter of fact, I won't talk about this today, but there's something called attention mechanisms, which are what solves this problem. And what you do is the words kind of gravitate around. So if you've been talking about fruits for a while, then your apple will sort of gravitate here towards the fruits. And if you're talking about, let's say these are computer companies and your apple is here, it will gravitate to the computer company. So that's, if you ever heard about attention mechanisms, they're really what made transformers work really well. It kind of moves the words around. But we're gonna go with the trivial answer, which is C, because we want to put the apple close to the fruits, right? That's an embedding. And what is an embedding here? Why am I turning words into numbers? Because I can associate to each word the horizontal coordinate as the first number and the vertical coordinate as the second number, and then I have my words go to pairs of numbers. So for example, let's say this is 5224, horizontal and vertical, and this is 5025. So those are the two numbers are associated to each word. And if the words are similar, then the numbers are similar, and if the words are different, like house is 10-4, then the numbers are very different. That's the main property of an embedding, okay? And I don't just need two, I can do more, right? I can send every word to 1,000 numbers, right? To a vector, a list of 1,000 things, and the numbers will be similar if the words are similar. So that is an embedding. And they don't only have to work for words, they can also work for sentences. So this is actually, I'll show you a demo where you can actually play with these. And you can plug in a sentence. Hello, how are you? And hi, how's it going? They're similar over here. And the car is red, the vehicle is blue, are similar over here. Because semantically they're similar. So you can see how powerful embeddings are, right? Like if you were to have a way to translate sentences or paragraphs or anything into a bunch of numbers, then you can do a lot of stuff, right? All of a sudden problems become much easier, right? So here's another example. This one I also did with the Cohere endpoint. A bunch of sentences that look similar. By the way, is it easy to read it from the very back? Probably not, right? That screen maybe, but I don't know. Anyway, I have a bunch of sentences here, and I send them to 10 numbers. And the numbers are up here as shade. And this one says, show me a list of ground transportation at Boston Airport, and show me Boston ground transportation. They're pretty much the same sentence, even though they don't have the same words, but they're pretty much the same sentence. And as you can see, the numbers are pretty close. So that's what an embedding does. The embeddings we use, Cohere could have 768 or 4096 numbers per piece of text that you enter. And at the end of the day, what happens is that each one of these entries kind of describes the word or the sentence. So in an ideal world, I would just think that maybe in an apple, like the first one is the color, then the shape. Obviously, it's not that simple. Sometimes there are properties that the model sees that we don't. But at the end of the day, if you think of it as a summarization of your text into numbers, that's a way to think of an embedding. You can also have, and then if you want to do this in code, just do code.embed and enter your text, and out comes a vector. So, pretty easy. Stop me if you have any questions, by the way. Can you still hear me in the back?
Yeah.
Thank you, okay. And then we have multilingual embeddings too, right? We have multilingual embedding that supports over 100 languages. And in these, if you send a sentence in a different language, you get similar vectors. So it works really well for, like, for example, translation or for searching. You can train a model in one language and search in another language or something like that. And it works really well. So here I put the same sentence English and French, and then the same sentence in English and Spanish over here. You can play with this all in the dashboard, which I will show you later. All right, so that was it about embeddings. Any questions about embeddings? Yes?
You have word embeddings, you have sentence embeddings. I think embeddings can be used for larger
Yes.
and lots of text as well. I'm just curious, what's the limit there? Is it like a
It's
big
a bunch
focus
of tokens. Yeah, I don't remember how many tokens you can throw in, but it could be in the thousands.
Okay.
Yeah, we can put it in. Like, sorry?
What was the question?
Oh, sorry. Yes, the question is: you can put words, you can put sentences, you can put text. How big can you go? And obviously you can't put the entire internet or something, but you can go quite big, and there's a token limit. It's not on the top of my head, maybe 4,096 or something. And by tokens I mean it's pretty much one word is a token, or sometimes a word has 2 or 3 tokens. But yeah, you can put big stuff there. Yeah.
What about emojis?
Emojis. That's a good question. I think I'm pretty sure you can put emojis there. Yeah.
Sound or images, more vectors?
Great question. These text embeddings don't work for images, but image embeddings are as well a big thing, and videos and then any data you have, you want to put it into an embedding. So yeah, like if you look at like Stable Diffusion or something, they first thing they do is put an image into a vector or sound. I saw one more. Maybe I'll just do one more and then I'll take the other ones again. Yeah.
When you showed the code sample where it said code.embed
Yeah.
and text, so that means there has to be some pre-configured training that has to be done on your model, right?
No, that's already trained. You
And
can
how
just
many-
go in.
How many tokens or how many dimensions does your model have?
I believe this one has 4,096, but there's different embeddings. One has 768. It depends on what you're doing. Some embeddings are good for search, some are good for something else, but it's on the hundreds or thousands. But all you need is just start your code and put your text, and you don't need to pre-train it or anything. Cool. All right, I'm gonna go ahead, and after embedding, want to talk about search. So search, of course, I don't need to introduce search. We all know what it is. But I do have a question. If you're given, a bunch of like a database or a data set or something, what are ways where you can make a search, a mini search engine on your data sets? Who has some ideas? Can help me out? Yes.
All the HTML in a database and check if the strings include what you're searching for.
Exactly, keyword search, right? Yeah, great, thank you. So keyword search would just be like you're searching for a string, and then you just look at where that string appears, right? If that string happens to appear, that's awesome. Or if not, at least the words, right? Like try to match as many words as you can to the string, and that works pretty well. Any other ideas? How else would you make a search? Yes.
Vector store.
Sorry?
A vector store.
A vector
Store.
store. Okay, and how would that work?
Well, you create these embeddings and then you put it into a sort of vector database and then you search for similarity.
Okay, similarity. Yeah. So like, okay, great. I'll get to that in a bit. So great idea. We search for similarity. We'll see what it is in a little bit. But yeah, the idea is that for a long time, keyword search was used, right? Could you tell me, for example, I'm going to search Brazil to USA travel visa. Who can tell me a small problem that keyword search would have? Something that if you search by matching keywords, it will work, but what cases could it perhaps not work? Yes?
It could be a scam. So if I wrote something on a website that says Brazil to USA travel visa and then put .scam, but if it shows up as a first result, then it would skew the resources.
Oh, if you put the word scam?
No, if
Sorry,
I
what?
put a bunch of whatever those keywords are, I can.
Oh, if
shrink
in
the
your
search engine.
web page you put every single word existing and then every search for yeah, of
So I
course.
can shrink the search engine.
Yes, that can be done. Yes, question. Sorry, answer.
It could be like the opposite direction. You want Brazil to USA, but
Exactly. Yeah, you read my mind. Oh, yeah, exactly. Yeah, you can find, for example, USA to Brazil travel visa, and that matches every single word, but it's wrong. It's not what I was looking for. As a matter of fact, it has probably nothing to do with what I was looking for, but it hit every word. And so keyword search, as great as it's been for a while since Google search started, it has its limitations. So what we want is something more than matching keywords, which is we kind of want the semantics. We kind of want something like this that doesn't have the same words, but it kind of caught what we're trying to say, like visas, U.S. Embassy in Brazil. So we need to kind of understand what's happening, right? We need the model to not just pick words, but to actually pick sentences, right? Pick meaning behind the sentences, and that's called semantic search. Okay? Any ideas on how we would do semantic search? Maybe with what I've told you before of the what we learned at the beginning.
Similarity.
Cosine similarity.
Similarity, cosine similarity would be what we do. Yeah. In other words, if I have embeddings, right? I have embeddings that turn text into numbers. I can use those numbers and see if the numbers are similar. So if I were to put these three sentences in an embedding, in my imagination, let's say they go here, right? And why are these two close and why are those two far? These two are far because they don't have the same meaning. Remember that a good embedding captures the meaning. An embedding may look at those and be like, hey, you give me the same words, but they're completely different meaning. Whereas these two are close because they have similar meanings. So you see how like a really good embedding makes everything much easier, right? All of a sudden, all I have to do is search for the closest thing. And that's a pretty good candidate for what I'm looking for, right? So that's exactly dense retrieval, right? That's how we search. We just take the query and look for the relevant documents. So here's another example that I did using the playground. I have 4 sentences. The capital of Canada is Ottawa, apples are red, Galileo invented the telescope, and a square has 4 sides, and they're somewhere in the embedding. And now I have the question. That's my data set. It's a small data set of 4 things. And my query is, what's the capital of Canada? And then I put it in the embedding, and boom, it's there. So I pick the closest thing, and it says the capital of Canada is Ottawa, and that's my answer. So that's dense retrieval. Any questions about dense retrieval?
Could you please give another example? To
Another
understand
example.
more of
What's that?
another example of dense retrieval. Like, could you go more in depth?
I mean, yeah, like in more depth would be like if you have, imagine if you have a huge database, and you can take every single sentence on your database or every single paragraph or any single document and put it into an embedding, and all of a sudden your documents are all over the place. And then you have a query, a question, you put it into the embedding, and then it's got to be close to something. So if you pick the things that are close, like if I'm the question and all of you are the database, I go, well, maybe you're the answer or you're the answer, right? And that's how it works. I make it look like in the plane because there's 2 numbers per sentence, but in reality there's thousands. You're just comparing what's the closest vector, and that's why cosine similarity came in, because you can see how close things are. But that's the idea.
Okay, thank you.
Okay. Yeah. Yes.
Can you just confirm why it's called dense?
What? Oh, that's a good question. No, I think just because the thing is, just because the data set is dense, I don't know.
Right? Yeah, okay.
Yeah, I guess if it's sparse, yeah, I don't know. Good question.
That's what I thought.
Yeah. Yes.
Let's say your database is not that complex, it's very small, and you ask it some query that has no similarity to anything that you have in the data set. So what would return? What would happen?
Yeah, it just wouldn't be good, right? Like if you answer a question that's not in the database that you're searching, it may just try its best, right? Like if I have a data set of, I don't know, like sports, and I ask it a question about, cooking, it will just get the closest thing, but it's not going to be good whatever I do, right? So it'll return the closest, but that's it. Yeah.
And speaking of dense retrieval, like what you said before, does the opposite also have maybe some, you get to the closest answer, the more similar all the responses have,
Yeah.
but would there also be a problem, let's say, in terms of bias?
Okay.
A good example of this would be if you try to use Dan on ChatGPT.
If I ask you what?
Dan, ask anything now.
Okay.
When you, for example, when you try to manipulate the web results into skewing one answer that may or may not be completely true, or versus what side of the story are you telling when you're asking this prompt? Like,
Yeah.
depending on what kind of responses or those responses you get from those dense retrievals bring back to you.
Yeah, that would happen. I mean, definitely bias is something that happens in the training, right? Like that happens in pretty much anything. But it's kind of hard to. Yeah.
happens, but yeah.
Yeah. A question. Yeah.
Could you help me understand the difference between what I imagine is like LLM-powered semantic search and similarity versus technologies that existed, up until I guess the birth of LLMs, like BERT models for semantic search? Are they the same thing, or like like natural language search, how it used to be, versus I don't know the new LLM semantic search or whatever that is?
Yeah, that's a great question. I mean, this looks simple, but it really uses building the embedding is pretty hard, right? So we would have done the same thing, I don't know, 10, 15 years ago with the embeddings we had back then, and not get as great results as now, because as you train an LLM, the embedding comes out somewhere, and and the better LLMs you have, the better embeddings you're going to have. So there's a lot of technology behind this, because I'm kind of taking the embedding for granted. But it's not. The embedding uses a lot of the power of an LLM, right? Yes. Cool. Okay, I'll keep going. So now I have a question for you. Just like I asked you for what is a bad example for keyword search, what could go wrong with semantic search, with dense retrieval? What could go wrong here? What can you help me think of a problem that it could have?
If you have large amounts of wrong unstructured data.
Right, large amounts of wrong.
Large amounts of wrong, incorrect unstructured data.
Yeah, it can tell an incorrect answer, right? If I say, what color is an apple, and an apple is red and an apple is blue, are just as similar. So you can't really tell. It doesn't tell correctness. As a matter of fact, it only tells you if a sentence is similar to another one. So if you say, what color is an apple, I can answer, what color is an orange? Well, that's not the answer. Well, that's the closest sentence, right? So that's a problem. That's a problem, right? And here's a little example. I have 4 sentences. The capital of Canada is Ottawa. The capital of Canada is in North America. The capital of USA is Washington. And the capital of Canada is in the moon. And I ask you the question, what is the capital of Canada? Well, all of these some of them are false, some of them have nothing to do, but all of them are similar to the answer, right? And this only checks similarity. So it answers, the capital of Canada is in North America, and it goes, done. Next question. And you're like, so that's hard, right? That's pretty hard. And ways to fix it, it's pretty much a research area. But we have a way to fix this that has worked really well. That is called re-rank. And so re-ranking is the approach. And basically what it does is it's a model that gets trained on pairs, question-answer that are correct, and assigns high scores to those, and on pairs, question-answers that are wrong, and assigns low scores to those, called a relevance score. So when you have that, then you can assign a relevance score to the pair question-answer, and then it's high for answers that are correct, and low for answers that are incorrect. So it's a very complex model that gets trained, but the way it works is like that, and it's a one line of code. It's pretty much code.rerank, and then you put the question as a string and the list of documents where you want to compare it, and it gives you the number for each one of them. You just pick the largest one. This doesn't only work for dense retrieval. This works for any search that you have. You can do keyword search and actually just return the top 100 answers, and then do re-rank on all of them. And it actually boosts keyword search pretty well. Question?
So this is like post-processing, right? It's not, is it part of the model itself?
This is a post-processing that you apply. So you can use your search, whatever search you have, just don't pick the top one. Pick the top 100, and chances are the answer's there, maybe at 47. And then you just apply re-rank to all of them, and that surfaces the good ones.
Thank you.
Yeah. It has given great results. Question?
It shows you how the
re-rank relevant scores and weight.
Yeah, pretty much imagine that you're training a model with pairs, and you give it a huge data set of question answers that are correct, and give it training to give high scores, and then a huge data set of question answers that are wrong or but close to it, like an apple is blue, you know, something like that. And then it just learns to give good scores to correct answers. It's a bit mysterious, but just so our neural networks, right?
So re-rank is another model that
Does it determine?
Yeah, here's your number. Yeah. Cool. How am I doing with time, by the way? Okay with time?
No, that's cool. No, that's cool.
Okay. I'm all all right, so dense retrieval plus re-ranking works beautifully, and that's what we call semantic search. When we think of semantic search, it's these two things together, and it just, you know, it's pretty much the state of the art on search. So I'm just going to do one last thing. Let's go into the cool stuff, which is chatbots, right? And so you've probably played with them long enough to tell me what is a potential problem that a chatbot has.
They apologize too much.
What?
So they apologize too much.
They do? Oh yeah. But what else?
Hallucinations?
Hallucinations, right? Hallucinations are the big problem they have, right? Because they're not trained to say correct stuff. They're trained to say stuff, right? They're trained on the internet to find the next word after a sentence. And the internet is not exactly a repository of truth, right? It's just a bunch of words, right? Like a bunch of sentences. So they're not meant to say correct stuff. They're meant to speak the language and to understand things and nuances of the language and sarcasm and whatnot. But storing information there is not the best thing to do. Okay? And they're also very confident. They're like that friend we have that, you know, doesn't really know that much, but is so confident they've always answered with confidence. So the question that I have for you is, how do you think we could fix that or make it a little better? Like, what would you do with your friend that always answers with confidence but may not be right? How could we help that person or that model? Yes.
So if the answer that they retrieve is like kind of distant from, you know, the query we put in, then can it not say, hey, I have this much confidence in my answer because it was kind of far?
That's a good idea. So train a model for confidence, right? Like we can also classify, use something to actually say, this is the answer with 10% confidence, or this is the answer with 90%. That's a great answer. Yeah, it's not the one I have, but that's a good one. And I would love to see that because, you know, I see these questions that sound so confident, this answer sounds so confident, and I don't know. Yeah. Offer a correction?
Yeah, so it learns, I guess.
Or if we give it a correction. Yeah, like that's also something we do, like post-training, basically. Like you train them with the internet, so they talk like the internet. And then you give them a bunch of correct data. Like you get, you know, actual correct data. So that's done a lot. They still hallucinate after that, you know? But that's the fine-tuning is something we do a lot for everything, right? For following commands, for answering questions. You just gotta give it to it because otherwise it doesn't. But even then it still hallucinates, right? So there's more stuff we can do. And actually there's a pretty simple solution. Take one more answer over here.
If we can give them more context about the thing that we're asking.
Exactly, yeah. And how would you give it context?
Maybe we can add more information about what we are asking. So for example, if we take ChatGPT as an example, we can provide what kind of role that we are asking it to play. So for example, if I'm asking it to be a scientist who works in chemistry, so we can give them the exact prompt to understand what we are asking and then generate a response.
Yeah, that's very good. So we say, for example, if I have a question about chemistry, I can just also tell it, you know, answer this in the chemistry way. That's a good one, very good one. Even better, we can actually use search to give it context, right? So we know how to search. So if somebody asks a question to the model, you can search that question and then give it that context. So you say, okay, answer the question. It's like if you take your confident friend and say, hey, what date was this independence of something, and they just answer with something, and say, no, but don't answer. Here's a book, and in this chapter, there's the answer. And I searched it, or I find it on Google, and then with that, tell them to answer from there. Because these models can follow orders. And if they're given the question and a huge paragraph for the answer, maybe they can answer the question from there. So that's it, right? It's called retrieval augmented generation. So here's a quiz, although I already told you the answer. But if I have two prompts for the model, I say, who won the UEFA Champions League in 2021? Or if I say, who won the UEFA Champions League in 2021? And then I give it a paragraph where the answer is there. Chelsea won the final 1-0, blah, 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 scored the goal. Which one do you think will give me a better answer? Thank you. You asked the second one. Obviously, right? Because I gave it where to find the answer. And so all I have to do is use searching, right? So if I train a model and try to have the world information inside that model, it may or may not work. It's hard to store information in the nodes of a neural network. But if instead I have my generation model, which is only meant to talk and follow orders, and I have information here, then I can do much better. And not only that, if you work at a company and you want to make the model only answer questions about that company or about the class you're teaching or about the topic, all you have to do is change the database, right? Like you say, answer questions from this database, and that's it. And even if you think you know the answer, if it's not in the database, say it's not there. Okay? That's retrieval augmented generation, and it works beautifully. And so we have it here at Cohere. It's called Cohere. I encourage you to try it. I have a little demo. So let me do the demo and hope for the best. Because I actually... Okay, so let's see. So this is the dashboard. Actually, let me show you a little bit. Here's the playground. And you can play with all these things. Generate, classify, embed. Here's embed, for example. I'm going to take you can add all the sentences you want here. Let me take some Reddit titles. There's all these, 55 of them. And then I run it. And here's what it does. It puts all the ones here about Queen Elizabeth, everything here about politics, Europe, everything here is about, a couple things, etc., right? So that you can see, I'm just so glad it didn't embarrass me. Okay, so this is embed, and let me give you Coral. So I have this. I'm going to type this one. So on Saturday, I went to the stadium to watch Toronto FC, unfortunately, lose horribly with Orlando. Sorry, no, not a lot for Orlando. But, so let's say who won the game between Toronto, let's just give it a soccer game. Sorry if this is too small. Maybe I'll make it bigger. Toronto FC and Orlando City on what date is today? September 20. Sorry, October 21, 2022. But here is where I can say, do I want to augment it with web search or not? So I'm not going to. I'm just going to ask it this. And then, that's not true actually. It wasn't 1-1. So it hallucinated a little bit. Actually, most of the time it just says, I don't know. But it pretended to know. It's a confident friend, right? But instead, if I ask it here, and I say, actually augment it, do web search. So search the answer and then answer. And please work. So let's see what happens. Orlando City won 2-0 on Toronto. This is it gave me a lot of information, and not only that, it actually gives me where it came from. So it shows it worked, right? If I click on here, it tells me just from ESPN. Here it got it from here, etc. Right? And that's much better than hallucinating, right? It even tells you the web page where it found the answer, and I can continue asking stuff, right? Like where was the game played?
There's a bunch of them.
So anyway, you can test it at coral.cohere.com. Give it a try. Yes.
Why are the first situation the bunches? I understand you got you backed up going to the web search, which makes sense because you have like reputable companies. But why is the first one hallucinating?
The first one I didn't use search. Oh, sorry, I didn't specify that for the first one I didn't.
You didn't, so like, because of that, why does it give you an answer that is incorrect? So like, what parameters does it define to say that I'm gonna give this answer, but this is not gonna give this answer?
Probably like temperature, which actually gives you like sort of entropy. If it's high, it gets creative. Let me try it again, because it normally just says, I don't know, or something. But the fact is, it just answers with no confidence. Because these models are trained to complete the sentence, right? To find the next. So it just kind of talks about soccer to you. It just goes, oh, you're talking about soccer, let me continue, right? So here for example, it goes, I don't have access. This is actually a more honest answer, right? I don't have access to real-time information, which is what you would get in any model, right? If you have ChatGPT,
You repeat the question multiple times. Is there like, is this equal like situation where you ask it so many times, it's gonna give you so much of a percentage of this is correct, this is not?
I don't know. I don't think it's gonna get it because it doesn't know. Like that data hasn't hit the training set yet. This happened on Saturday, so it's as good as anyone's guess, right? If it has maybe would be that if I ask it in a few years or in a few months with the data, that it may be able to, but there's no reason to it, right? Yeah. Okay. So that was the demo. 5.3 now it says. It's just all over the place. I don't even, yeah. Anyway, let me go back to the presentation. So now we can go back to, what I showed you at the beginning. Today I told you about embed, re-rank, and the chat and chat plus RAG. So RAG is retrieval augmented generation. This is the one that finds it and then answers. This is the one that just answers. Embed, well, to the embeddings, and there's a few that I didn't mention, but just basically the idea of the suite of endpoints. I guess what I was going to do. Sorry. And just to finalize, before we get to questions, I'm just going to give you some more resources. If you want to learn more about this, LLM.university. Who has seen LLM University? Yay, that's awesome. That's where all this material is by myself and Jay and Mior and other great instructors. We have basically all the information about LLMs. There's conceptual stuff about transformers, attention, this stuff in search, embeddings. Then there's a bunch of code labs about all the endpoints. Then there's prompt engineering, basically even deployment. So there's deployment in different platforms. Anything you want. So check it out. LLM.university. We're always adding stuff there, and we're very proud of it. Check out the Cohere blog. We have a lot of great stuff there. And also, the dashboard that I showed you, play around with it. You can also sign up and receive a trial key, and then play with it all you want. Highly recommend it. If you want to follow me, I do have a YouTube channel. Has anybody seen my YouTube channel? Serrano.academy. I put a lot of videos on machine learning, this stuff, and also other different stuff. So definitely check it out. And my colleague Jay has an amazing blog. The illustrated transformer is pretty much the best I've seen in explaining. That's how I learned transformers. So definitely check it out. And then some other things. Please feel free to sign up. Here's the code. I'll give you a second if you want to take a look. This is for signing up to get an account and use the dashboard. I'll give you a minute. When I see both down, I'll pass it. If it's too far, you can use that screen. Then we have a Discord, a very active Discord for Cohere and for LMU, and also for Cohere for AI, which is our research wing. They do amazing work. So definitely check out the Discord. I saw a lot of people looking for a job, so definitely please check it out. We're always hiring in all positions. We're growing pretty fast, so please take a look at that. I'll leave that for a little longer. Thank you very much for your attention and for answering all my questions. Should we do questions live or stick around? Yeah, I'm happy to take questions. Please be gentle. Yes.
For the last web search that you added, are these retraining your model? Like, are you adding retraining the weights with this new information that's coming from the
Great
web?
question. No, the model's been trained. This is more like a little aid that you give it, right? So you search it, you find the answer, and then you just change the prompt. So the same model, just with a different prompt. You don't just ask the question, you also give it where to answer from. So yeah.
So in that way, you probably protect your model of injecting information that you don't want to get in.
Yeah, I mean, exactly. It's not that much you can do to retrain the model back. Like even if I answer it wrong, like if I want to confuse it and I go, oh no, that was wrong, but it was right. That's a tiny, like a drop in the ocean. So I wouldn't say that you actually harm the model by inputting like that. But it definitely helps you find more accurate answers because it's hard. The model's weights may be all over the place and it could just hallucinate an answer. But actually, if you're using Google search or actually searching like strict databases that are sort of more trustable, then that's better. Right?
But the thing is that at some point you find that your model is hallucinating a lot and you want to get a stronger model that you want to verify the information, the truth source, and have a better trained model probably. Yeah. But at the same time you want to protect your model for misinformation.
Yeah.
So is there any way to get a stronger model, like retrain or add? And at the same time protect from misinformation?
I don't know what level, but they do get retrained. If you say this was correct or put a thumbs up or a thumbs down, they do get retrained. Probably not as much as what you actually do to train them, right? So like you would just, get more, experts to write stuff or feed it more like correct data. Like that's more like what you would do to make a model be more correct, But at the end of the day, even if it's super trained, these models are not meant to carry data. They're meant to know how to talk. They're very continuous. They're meant to, they can understand things, but they're not meant to store information. So if they say correct stuff, they may, but it's not their main, it's, the training doesn't help that much. So yeah, if you train them with a lot of data, they're more and more trustable, but I would still, I think search is something that can always be used to improve it. Question here, and then there, and then there.
Two questions. The first one is simple, which is what does Cohere mean if it means something? I'm just curious.
You're the one with the hard question.
The second question is just around the state of development. Is the model called Coral? Is that what it's called?
Coral. Yeah.
And just about the state of development of Coral, is it developing quickly? Is it at a stage where development is slower now and you're very happy with where it's at? And if it is being developed quickly or looked at, what are sort of the direction that it's going into now? Or the main
so I'll give you a fun. Actually, Cohere. I don't know why it's called Cohere, but I guess it's coherent. Maybe. I don't know. Yeah. I'll just give you an anecdote. When we do the courses for LLM University for prompt engineering, it's pretty hard because we say, hey, if you do this type of prompt, you get an error or you get something bad. And then try this instead, right? Like what I did, right? Like a bad example, like a before and after. And then a month later, we try it again, and it works with the previous one, right? So it goes really fast. Like each iteration gets better and better and better, and they're constantly trained with more and more and more data. So they would change pretty quickly. Like in a month, I just look at it and maybe it's different. Like maybe if next time you see me here in this talk, I'd have to get a different example because it will answer your questions correctly. So it goes pretty fast. Yeah, you're always putting in different use cases, like make it work with code, make it work with this. Like we look at weaknesses and go, okay, let's give it more data like this so that it does this better.
And what about just industry in general in terms of use cases to which it's being applied for customers? Are you finding that the state at which it's at right now can sort of solve most problems?
Yeah, this works pretty well for a chatbot and for a company or things like that. But of course, it can always get better. But it's pretty functional for the use cases. The enterprise use cases are working pretty well. Yeah. Cool. Thank you. We have someone here. You? Yeah. And then
I also have two questions.
Yeah,
First
sure.
question is about the re-rank that you mentioned. Since that's a model ranking in another model, and that re-rank model doesn't have correct context where maybe whatever context of text that you're measuring.
Yeah.
Won't you have like the same? Can't you have the same flaw for the re-rank?
Of course. Yeah. It's a stronger one because it's not so much based on similarity. It doesn't. The embeddings are trained solely for similarity, right? So like they will capture if two sentences are similar, and that's it. Re-rank is actually super trained on correctness, just by the data, right? Like you don't do anything to say be correct or not. You just give it a lot of question answers that are correct and a bunch of wrong ones. So in some way, it's optimized for that, right?
Is there a specific context that's for re-rank, or do you use it as a general purpose? Can you use it as a general purpose for example context?
Yeah, pretty much general purpose. But the point is you try to separate it as much as possible. So you try to trick it, right? Like you give it the correct answer, but you give it like 10 answers that are so close to correct, but they're not, and you say, send those there, right? Or you can also do it with, you can also optimize your embedding, right? Like you can also take your embedding as it is, and then be like, well, this pair is really close, but it's a bad answer, so make them far away, and then these two are correct answers, so push them close together, and eventually if you do that with a lot of them, the embedding somehow mysteriously learns to put things closer when they're correct. So it is mysterious, but just the fact that the data that you give it looks like a certain way, it just mimics that.
Is re-rank another type of similarity neural net that you guys train?
It is a neural net, and it pretty much captures, yeah, it's more like captures relevance, right? So
why wouldn't can't you just use that re-rank model for that as well?
that's a great question. Why didn't I just start with re-rank, right? Like, why don't I just take the entire set of documents? And the answer is just, it's slower. Like, so it just, you can't just fit that much stuff on re-rank. So one kind of surfaces the good ones. Like, whatever search model you use surfaces the good ones, and then among those you can use re-rank. But it'd be expensive to use re-rank on a huge database.
So have you guys also done like some quantization to make it into a smaller model?
We're always trying to make things into a smaller model, and you know, something much smaller that works just almost as well. Yeah, we're always trying to.
Also, I have another question about the web-based search. How does that work? Is that doing a Google search and then we're going through a bunch of different documents, and how many documents is it going through?
It's a good question. I don't know how many it does. It just picks a bunch.
Like the top 10.
There may be like. Yeah, I wasn't
like
reading it, but it does
Google
take.
search.
Yeah, it takes some of the documents. Yeah, that's a good question. I'll find out.
You gave us an example in a 2D space of how sentences are related to one another, and you said that there could be like thousands of vector points for anyone. Now, is that just to construct, an infinite number of possibilities, and then things are constantly re-ranking themselves with one another, or could one vector point, say, relate to something like geography? There's no meaning to the vector itself; it's just where there is.
I see. So what happens in 2D pretty much is a picture of what happens in the 1000D, right? But you do see regions, right? Like in a huge space, this would be like 3 coordinates, right? In space. But if you have 1000, it would be like a 1000-dimensional space. But you can still think of having regions there, right? So as you said, like if everything here is geography, then most things I say are here, and then maybe here is history, and here is like sports or something. You do notice that, and so in the demo I did of embed, you can see that. And actually, you should play with it. Like if you go to embeddings and put lots of sentences of something, you'll notice that they all go to the same places. Was that your question?
Yes, and are the values for any one sentence changing in the relationship to
I mean, if you have a fixed embedding and I put the same sentence, I get the same numbers, right? If I change it a little bit, it changes. But it's it's a process that just goes through the function and outputs the same thing. So it doesn't change. Obviously, if the embedding gets retrained, then the numbers change slightly. But no, it always gives you the same thing.
Cool. So just in the interest of time, we might need to do follow-up questions after this.
Sure, I'll be here.
Does that work?
Okay. Great. Good.
Cool. Well.